Hello and welcome to my tutorial on heat and temperature. Today's learning objective is to understand the difference between heat and temperature. So what is the difference between heat and temperature? So heat is a form of energy. It's measured in joules and it's often called thermal energy. It's a total kinetic energy of the particles in the substance. Kinetic energy causes particles in a substance to vibrate. So if an object gains heat energy, its particles will start to move more. Now, how does this compare with temperature? Temperature is a measure of how hot or how cold a substance is. And it's measured in degrees Celsius or Kelvin. Temperature is the average kinetic energy of the particles in a substance. So if you were shown two diagrams like this, that substance here, the yellow one, on the left-hand side, and you have another substance here, the blue one, on the right-hand side, which substance would have the highest temperature and which would have the greater amount of energy? So how would you tackle a question like this? Well, first of all, you might look at this substance here and you might say, right, okay, how many particles have I got here? Now you've got 8 particles. Now what is the sum of the energy, the total energy for that substance? So what you would do is you would add all of the energies together. So you've got 2 joules, 3 joules, 2 joules, 3 joules, 2 joules, 2 joules, 2 joules, 4 joules. So the total kinetic energy of the particles is 20 joules. Now to work out the average kinetic energy of that substance, we divide 20 by 8 because we've got 8 particles in total. That gives us an average kinetic energy of 2.5 joules. Now, if we do the same for this blue substance here on the right-hand side, the total kinetic energy of those particles is 27 joules. But because you have 20 particles here, 27 divided by 20 gives you an average kinetic energy of 1.4 joules. So what do we remember about temperature and amount of energy? Well, the substance with the highest temperature is a substance which has the highest average kinetic energy of its particles. Whereas a substance which has a greater amount of energy is a substance with the higher total kinetic energy of its particles. So that means this yellow substance on the left-hand side has got the highest temperature because it's got the highest average kinetic energy of its particles at 2.5 joules, which is higher than 1.4 joules. Now, this blue substance on the right-hand side has got the greatest energy because its total kinetic energy is greater. So you can see that this has a total kinetic energy of its particles of 27 joules, whereas for this one here it's only 20 joules. So if you were given a question like this one and you were asked which has a greater amount of energy, this pot of hot chocolate sauce at 60 degrees C, or this large bowl, this ice cream sundae at -7 degrees C. So which has a greater amount of energy? This ice cream or this hot chocolate sauce? Pause your video now and try to explain your answer. Right, okay. Your answer should have been the ice cream sundae. And the reason why the ice cream sundae has the greater amount of energy is because we know that heat energy is a total kinetic energy of the particles in a substance. The more molecules something is composed of, the more energy it has. Now, that ice cream sundae has a much larger mass and therefore far more molecules than the chocolate sauce. Although the ice cream's molecules vibrate slowly, the combined total kinetic energy of that ice cream sundae is going to be greater than that of the hot chocolate sauce. Now, temperature is just a measure of the average of the kinetic energy. The number of molecules doesn't matter. This is why the hot chocolate sauce has a higher temperature. The chocolate sauce has far fewer molecules and these move more quickly. So you might be given a question a bit like this one in your exam. You have two beakers and they both contain water at 20 degrees C. The first beaker contains 800 milliliters of water. Your second beaker contains 150 milliliters of water. Now, just a note here, 1 milliliter is equivalent to 1 cubic centimetre. So if you're told that you have 800 milliliters, that's the same as saying that you've got 800 cubic centimetres. Similarly, that would be 150 milliliters or 150 cubic centimetres. In addition, 1 milliliter of pure water has a mass of 1 gram. So if this is pure water, that would be 800 grams of water here, and that would be 150 grams of water here. So if we look at the question, if you added 25,000 joules of energy to both of these beakers, how would you expect their temperature to change? So if this one had 25,000 joules added to it, and this one also had 25,000 joules added to it, would you A, expect their temperatures to increase by the same amount? Or would you B, expect the 800 milliliter beaker to reach a higher temperature? Or C, the 150 milliliter beaker to reach a higher temperature? Pause your video now and write down your answer and explain why you've given this answer. Right, your answer should have been the temperature of the 150 milliliter beaker of water increases by much more than the temperature of the 800 milliliter beaker of water, which was option C. Now, your explanation for this should have been very similar to this. As temperature is a measure of the average kinetic energy of the particles in a substance, as you have far fewer molecules of water in 150 milliliters of water, each molecule will receive a greater share of that 25,000 joules. So in the 150 milliliter beaker, the water molecules will have a higher average kinetic energy, and so will move more quickly. Right, you might get an exam question that looks like this. So here you have two beakers, beaker A and beaker B. Beaker A contains 400 millilitres of water and beaker B contains 800 millilitres of water. Now, both beakers of water had starting temperatures of 20 degrees C. 16,720 joules of energy were used to raise the temperature of beaker A by 10 degrees C to 30 degrees C. So it was initially at 20. The temperature was increased by 10 degrees C to give 30 degrees C. And that required 16,720 joules of energy. Now, your question might be, how much energy is needed to raise the temperature of the water in beaker B by 10 degrees C2? So the first thing you would do is you would compare the volumes. You can see that that's 400 millilitres there. That's 800 millilitres there. You've got twice the volume, which is twice the mass. So how would the energy compare? Now pause your video and try to answer this yourself first. Try and explain your answer. Once you've finished, press play. Right, your answer would be you would need 33,440 joules of energy. That's double the energy that you required to increase the temperature of beaker A by 10 degrees C. And that's because if you double the mass, you must double the heat energy to heat it to the same temperature. So because you've doubled the mass, you would need to double the energy. Now, I hope today's tutorial has been useful to you. In our next tutorial, we will be looking at conduction.